warm welcome to all the viewers. In today's session of Tourism and Hospitality Research, I'm going to discuss with you when and how to conduct the t-test. We are talking about an independent sample t-test, also known as student's t-test, which is used to compare the means of two groups. The assumptions of t-test, how it is different from a z-test, and how to do it practically and interpret the results via SPSS. So I'm going to show you all of them. Stay tuned, keep watching. T-test of independent samples, also known as student t-test, is used to compare the means of two groups when population standard deviation is unknown and the sample size is small, usually less than 30, but you can take it up to 60, 50 if you are assuming the normality of data. While a chi-square test is used to examine the relationship between categorical variables, test of independence or association, or to compare the observed and expected frequency, that is chi-square test of goodness of fit. In case there are more than two groups, then we go for ANOVA, that is analysis of variance. Z-tests are typically used for larger sample size, where the population standard deviation is known or can be accurately estimated. So now, in just one slide, I've tried to explain to you when to use a t-test, how it is different from a chi-square test, and ANOVA and Z-tests. The assumptions of t-test. T-test assume that the data is approximately normally distributed and the groups exhibit homogeneity of variances. So the Levene's test of homogeneity of variances has to be insignificant, that is greater than 0.05. While this assumption is important, t-tests are considered relatively robust, meaning they can still provide reasonably accurate results even if the normality assumption is not perfectly met, especially in the case of smaller sample sizes. T-test uses the sample standard deviation because the population standard deviation is unknown in this case, and it uses this to estimate the population standard deviation. So let us have a null hypothesis over here. That is, there is no significant difference in understanding between the two groups which are male and female. The categorical variable was gender, under which I have two categories, male and female. And there has to be a continuous variable on which we will compare and see whether there is a difference between males' perception and females' perception on that continuous variable. The procedure to do t-test in SPSS: you go to analyze, compare mean, independent sample t-test, enter the target variable, that is continuous numerical variable, that is to be compared between the two groups, and enter the grouping variable, that is a categorical dichotomous variable. In our case, it's gender, male and female. Tick on estimate effect sizes, confidence interval percentage has to be 95. What does it mean? CI means if the same experiment is repeated, then 95% of the times the achieved result will match the study's results and it will lie within lower confidence interval and upper confidence limits. So in that case, there will be no zero coming in between the lower CI and upper CI. And that indicates that the result is significant. And if the same experiment is repeated, 95% of the times we'll achieve the same result as we got. Missing values, exclude cases analysis by analysis. This option will be ticking in SPSS. Homogeneity of variances has to be insignificant, mean difference and standard error difference, that is t value. So you divide the mean difference by standard error difference to get the t value, which must lie between minus 1.96 to plus 1.96 in order to indicate a normally distributed data. So let us check it out, how to do it in SPSS. So here we are in our SPSS file. We have one variable, a categorical variable gender, where one denotes male and two denotes female. We have 60 cases you see here, case ID 60. We have 60 cases to be analyzed. And I want to compare whether there's a significant difference between male and female's understanding or their perception about the behavioral intention. First thing I'll do over here is that I'll check the assumption of t-test, that is my bi variable is normally distributed or not. For that purpose, I go to analyze, descriptives, explore, and here I enter my bi variable in the dependence. I go to plots, click on histogram, unclick stem and leaf, check normality plots with tests, click continue and click OK. Now I see that there are 60 cases, no missing cases, and let me check the skewness and kurtosis of my bi variable, that's a dependent variable. The skewness in this case is 0.983, kurtosis is 1.052. If I go with certain references, which I showed you in the previous video, I can say that skewness limit up to the level of plus 2, ranging from minus 2 to plus 2, can be assumed to be normal. So this is 0.983. So we can go ahead with the analysis and say that our data was normally distributed. Though it was not perfectly normally distributed, you can see here it is skewed towards the right, positively skewed, but still I can go ahead with the analysis. As my sample size is large, it's 60, so t-test is robust to the violation of normality in case the sample size is large. So let me check out whether there's a difference between male and female's understanding of behavioral intention. For that purpose, I'll go to analyze. So I'm here in my data sheet once more. I'll go to analyze, compare means, independent sample t-test. And in the test variable, I'll enter the BI, and the grouping variable is gender. Define groups. The value for group 1, that is male, is 1. The value for group 2, that is female, is 2. That's the value in my data set. I click on continue and I go to options, exclude cases analysis by analysis, confidence interval percentage is 95%. I click continue and then I say okay. So I get the results. Now you see here, there were 31 male and 29 females. The sample size was 60. The mean in case of males was 2.45. In case of females, it was 2.56. Whether there is a significant difference between these two means of male and female. That's why we are doing an independent sample t-test. I'll see the Levene's test of equality of variances. Now you see here, the significance value is greater than 0.05. That means it is insignificant. So equal variance is assumed. This is insignificant. So in Levene's test of equality of variances, we do not reject the null hypothesis, which is equal variances are present between the two groups. That is the null hypothesis for Levene's test of equality of variances. So as the p-value is greater than 0.05, we fail to reject the null hypothesis and we say, yes, there are equal variances between the two groups. And now let us check whether this is significant or not. So the significance level is 0.599, that is greater than 0.05, which means there is no significant difference between the means of male and female group on the variable that is behavioral intention. Had this value been less than 0.05, I would infer that there is a significant difference between the male and female's mean value. So this result told me that there is no significant difference. I can verify this result by looking at the lower confidence interval and the upper confidence interval as well. As you can see, the lower value is minus 0.52042 and the upper value is 0.30296. So there's a zero coming in between the lower CI and the upper CI. That means it is insignificant. The difference is insignificant. So I conclude that independent t-test was conducted to compare the mean value of male and female over behavioral intention, and it was found that there was no significant difference between the perceived behavioral intention of males and females. I hope this video was quite informative and interesting for you, and you learned how to do independent sample t-test and interpret the results easily via SPSS. Keep watching and keep learning for more. Thanks a lot.